Hi everybody. We are ready for section 3.3. Section 3.3 is all about rate of change and slope. Hopefully you've heard of slope before. It's a really helpful thing to know if we're graphing or looking at different things. So a couple things to say about rate of change. First of all, rate of change is a ratio that describes, on average, how much one quantity changes. A ratio, remember, is a fraction. So we typically don't mind fractions when we're dealing with slope. It describes how much one quantity changes. And our rate of change is the change in y over the change in x. So we could think about how much does your paycheck change as you work more hours. Hopefully your paycheck will increase. So your change in your pay will increase as your change in your hours increases. And talking about linear functions, if we graph them, there's a constant rate of change, which makes it a nice, neat, straight line. If the rate of change was all over the place, if 1 hour you made $5 and the next hour you made 15 and then the next hour you went down to $2 for that hour, it wouldn't have a constant rate of change. So let's look at these two. Remember, I always try to do practice problems that are like the problems I'm going to ask you to do. Use the table to find the rate of change, then explain its meaning. So we said it was the change in y over the change in x. And that was what our rate of change equals. So I'm going to start with the x's because it's on the left. How are the x's changing? What's our pattern? It's going up 2 every time, right? How is our total cost for our computer games in this first table changing? It's going up by how much? Should be 78 if I'm doing my math right. So it's saying for every 2 computer games you buy, your cost increases by $78. So what would that mean? Notice my change in y, my pattern, plus 78 over my change in x, which is the pattern 2. So how much would what would be a rate of change for just 1 computer game? So $39 is the rate of change. You pay $39 more for every game you buy. Does that make sense to everybody? All right, let's do the second one real quick here. So my x values this time are my time driving in hours. So from 2 to 4, 4 to 6. My change in x's, just as a coincidence that it's 2 again. It's not always 2. What's my rate of change for my y's? I think it's going to be 76. So for every 2 hours, we go 76 more miles. So what is my change in y over my change in x? So 76 over 2. So that's saying for every 1 hour, we drive 38 miles. It's kind of like that unit rate as well that we talked about. All right. So now let's relate this to slope. First of all, the letter for slope is an M. I don't know why you'd think it was going to be an S or maybe even a P, but it's an M. It tells the steepness of the line, how quickly things increase or slowly. And a lot of people know it as rise over run. If you've got a graph, you can count the rise, how far up or down, over the run, how far across. Up or down is the y direction. Over run is the x direction. So it's always y over x. And our formula, make sure you've got that. M equals y2 minus y1 over x2 minus x1. What are your change in y's over your change in x's? So let's do a problem or two. So number 3, we're going to do this one. It says to find the slope of the line. Find a slope of the line that passes through -1, 2, and 3, 4. Well, I put a piece of graph paper there so that you could see it. I want you to see rise over run, and I want you to see the formula. So graph the point -1, 2. Graph the point 3, 4. I'm having a hard time seeing these points right here. Put yourself a nice, neat line through it. If we're going to count rise over run, That's asking how far up do I go to get from this first point on the left to the second point? How far up do I go? I think it's 2. It's hard to see on my graph. So we go up 2, and then how far across do we go? 4. So our rise is 2 over our run 4. Of course, you're never going to tell me that it's 2/4, right? What are you going to tell me your slope is? Simplify that to 1/2. If you like a formula, let's do this. Does everybody agree that's an x and a y? And I'm going to put 1s there because that's my first point, or first ordered pair. This is also x and y, but I'm going to put 2s there because that's my second point. We know that the formula is that. So let's just put them in there. We're going to do the numerator, do the denominator, and then deal with that fraction. So y2 minus y1, 4 minus 2 over x2 minus x1, 3 minus -1. Everybody knows what happens to a minus and negative, right? So that gives us a 4 minus 2 is 2, 3 plus 1 is 4. Simplify that to 1/2. So 2 different methods to find that slope. You don't have to do both of them. Either choose the formula or count on the graph. Rise over run. All right. Let's skip number 4. I'm actually going to save this one for the practice problem at the end. So I'll be looking for that one to be complete. All you have to do is find the slope. Either do the formula or do the rise over run, graph it, whichever one you want. So if it's not graphed, I'm going to be looking for the formula. This one's an unusual. Let's do it at problem number 5. It says find the slope. Our points are 1, 2, and -1, 2. So I'm going to graph those. Over 1, up 2, and back 1, up 2. Well, if I connect those dots, would you agree that that is a horizontal line? So if we're thinking rise over run, how far up and down do I go to get from the left, this guy, to the other one? I don't go up at all, right? So what do we put when there's nothing at all? And the run is 2. I run to get from one point to the other. So 0 over 2 is the same as 0. Not a no solution. It's a big old 0. If I'm going to use the formula, x and y, that's my first point. X and y, that's my second point. So y2 minus y1, 2 minus 2 over -1 minus 1. Notice this time I get a 0 over -2. It doesn't matter what you put into your calculator, 0 divided by 2, 0 divided by -2, it's still going to be 0. Because I don't care if I'm going over 2, if I'm running 7, if I'm running 1,000. I just know that I'm not rising at all. So 0 for my slope. Make yourself a note, 0 slope is a horizontal line. And I'm going to skip number 6 as well. So we'll save that one. We'll do that one probably in class. And the summary boxes, we're going to talk about these in class too because there is a lot of information there that we can use and kind of go. So last but not least, find a point if I give you the slope. So you know M, but you don't know a point. So the first thing you're going to do is use your slope formula, fill in what you know. Slope formula we already wrote down. M equals y2 minus y1 over x2 minus x1. Solve. Cross multiplying is usually the easiest way to do it. That's why we had to do that cross multiplying section in the last chapter. And then find the value of that missing coordinate. So we'll have one thing missing. All right, so let's do an example. It says find the value of r. So the line through r6 and 10, -3 has a slope of -3/2. So it says to use the slope formula. So let's jot that down. Let's look at the words up here, figure out what we've got. Well, first of all, this is an x and a y, and it's my first point. This is an x and a y, and it's my second point. So I've got an x1, y1, x2, y2. Notice my x1 is an r. That's all right. I can still do that. And this right here is my m. So I can put my values in there. When I write -3/2, I'm going to put -3/2. As long as there's a negative on there, it's still all right. Equals, so what's my y2 minus y1? -3 minus 6. x2 minus x1. Everybody see where I got that from? -3 minus 6. x2 minus x1, so 10 minus r. Now this looks just like an equation from chapter 2. Let's cross multiply this. Notice when I go this way, I'm going to do distributive property. I'm going to bring my equal sign straight down that line, just like I've been doing. So I'm going to cross multiply and do -30 plus 3r. Everybody agree on my signs there? When I go this way, I better do this little math, because this seems like a lot of extra work, right? What's -3 minus 6? I think that's going to be -9. So now when I cross multiply, I can just do -18. If you wanted to distribute and then combine those like terms, you certainly could. You'd get a -6 minus 12, which is still a -18. So when I solve this equation, I'm going to add 30, add 30. So I'm going to get 3r equals 12. So it looks to me like r should be equal to 4. So when I look back at this problem right here, that has to be a 4 in order to make everything work. A little tricky, but you guys know how to cross multiply, you know how to distribute. So really putting the stuff in there and labeling everything is really important so you can keep track of those things. All right, so lesson summary. Whoa, there it is. What are the 2 ways to find slope? We don't even have to say on a graph. What are the 2 ways to find slope? Be specific. I mentioned that already. And your practice problem I mentioned was going to be problem number 4. And I do want you to sketch it. I want to see the graph. I know I said it before I didn't want to, but I see now that I do. So find the slope, but you can either use the formula or you can count, whichever you need. It might look a little weird. No, it might look a little negative when you get that answer. That is it for section 3.3. We'll do a couple examples and we'll fill in that concept summary box so that everybody can see what we've got. And then we'll go on from there. Bring your questions to class with you. We'll see you tomorrow.